Hello everyone, myself Dr. Santanu Kundu. I welcome you all to this lecture of soft computing techniques. This is the fourth lecture of module 9. So till now we have covered indeterminate relations, lower approximations and upper approximations. There we have lower approximations that is the set approximations. Let T equal to the sets of objects and attributes that is UA, and let B is which is subset of attribute set, X is subset of objects. We can approximate X using only the information content in B by constructing the B lower and B upper approximations of X denoted by B underline X and B overline X respectively. That is, the B underline X, you can say that is lower approximations, and this is known as upper approximations. So here B underscore underline X is the set X for these equivalence classes are completely within the target set. Here in upper approximations the intersection is not equal to 5, so that is equivalence class, and the target set intersection is not equal to 5. So lower approximation of X is collection of objects which can be classified with full certainty as member of set X using attribute set B. So that is B underline X, and upper approximation of X is collection of objects that may be possibly classified as member of set X, that is B overline X. The boundary region of X, that is B and Bx, is the difference between the upper approximations and lower approximations. So boundary region is the difference of the upper approximations and lower approximations, means those who are present in the upper approximation but not in lower approximations. So this consists of those objects that we cannot decisively classify into X in B. The outside region of X, so that is the object minus upper approximation, consists of those objects that can be with certainly classified as not belonging to X. A set is said to be rough if its boundary region is non-empty. I mean, the upper approximations minus lower approximation is not equal to 5, then it is rough set. Otherwise, if these two are equal, then you can say the X is a creep set with respect to attribute B. Now, why is the boundary region important? The boundary region is crucial because it helps identify areas of indeterminacy or uncertainty within a given data set. In many real world applications, we don't always have complete information about all elements of a set, and the boundary region captures that uncertainty. Here is more detailed breakdown of each component. Lower approximations. The elements in the lower approximation are definitely part of the set. This means we are sure based on the available knowledge that these elements belongs to the set. Upper approximations. The elements in the upper approximations could possibly be a part of the set. These elements may not be definitely be the set, but there is enough information to say they might be included. Boundary region. The boundary region is made up of the elements that are part of the upper approximation but not in the lower approximations. These are the uncertain elements. We know these elements could belong to the set, but there is no certainty. Real world applications of boundary region. The concept of the boundary region is commonly used in areas where classification or decision making is based on incomplete or imprecise data. For example, medical diagnosis. In a medical context, the lower approximations could represent patients who definitely have a disease, while the upper approximations could represent patients who might have the disease based on the test result, symptom, or etc. The boundary region might then represent patients whose condition is unclear and further tests may be needed to confirm whether they have the disease or not. Data mining. When clustering or classifying data, some data points may not fit neatly into any one cluster. The boundary region in rough set theory helps identify those data points that are ambiguous and may require additional refinement or different methods to classify. Why boundary region is useful? Number one is handling uncertainty. Many real world problems involve uncertainty or imprecision. Many real world problems involve uncertainty or imprecision. The boundary region gives us a clear representation of which elements are uncertain. Refining classifications. In data classification, recognizing the boundary region helps in improving classification accuracy by focusing on those uncertain cases and potentially revisiting them for better understanding. Decision making. In decision theory, you can make more informed choices by identifying regions where decisions are unclear, which helps refine strategies and predictions. So now we are going to solve one example. So let we have a universe that is simple x equal to 1, 2, 3, 4. Here attributes. Suppose A is the attributes. So that is basically you can write it A, B, C. So indiscriminate or equivalence classes for A is 1, 2, this is same 3, 4. Target set A equal to 1, 3. Now here you can say that 1 and 3. So 3 is completely subset of the target set. So lower approximation of 3 is there. Since only 3 is certainly in A. Now this set and the target set intersection is not 5 for these two cases 1, 2 and 1, 1, 3. So upper approximations of A is 1, 2, 3. Since two equivalence classes, these are 1, 2 and 3 intersect with A. So boundary region is upper approximations minus lower approximations. So here boundary region is lower approximation is upper approximations minus lower approximations. We will get it 1, 2. So here 1 to indicating uncertainty about whether 1 and 2 belong to the set A or not. Data set example. Another example. So let's consider a universe of x1, x2, x3, x4, x5 and we assume the following equivalence relation based on a certain attribute. These will divide the universe into equivalence classes. So attribute values A 1, 1, 2, 3, 4. So here the indivisibility of the A is these two are same. So x1, x2, x3, x4, x5. With target set we define as A equal to x1, x3 and x4. So you can write it A1 or you can write it A1. So indivisibility of A1. So now we will apply rough set theory to find the lower approximations, upper approximations and the boundary region. So step 1, define the equivalence classes. From the table above, the equivalence relation divides the objects into following equivalence classes. We have seen this that x1, x2, x3, x4, x5. As this is same value, these all are the unique values. Step 2, find the lower approximations. The lower approximation consists of elements whose equivalence classes are entirely contained within A. So x is x1, x2. So x1 belongs to A, but x2 not belongs to A. So x1 is not complete inside the target set. x3 belongs to A. So x3 is completely inside the target set. x4 also complete inside the target set and x5 is the outside. So you can write the lower approximations of the target set is A is x3, x4. So that is the lower approximation. You can write like this is equal to A bar x. So now find the upper approximation. So the upper approximation consists of the element whose equivalence classes have at least one element in it. I mean the intersection is not the null set. So x is x1, x2. x1 belongs to the target set, so that will be the in the upper approximation both x1 and x2. x3 also belongs to that, and x4 also belongs to that. So these two belongs to the upper approximations. x5 is not. So here the upper approximation is that x1, x2, x3, x4. So you can say the boundary region is the difference between the upper approximation minus lower approximation. So that is x1, x2, x3, x4 minus x3, x4. So that is x1, x2. Here you can say the outside the region is universal minus the upper approximation. So you will get the outside region is only the x5. Outside region is only the x5. Outside region is u minus b upper x, which is only the x5. Now summary, the numerical example demonstrates how to calculate the boundary region in rough set theory by defining lower and upper approximations. We can pinpoint the elements that fall into the uncertain category represented by the boundary region. In real world application, this helps to handle situation with ambiguity or insufficient information. Now try to understand another example. So here is the objects are x1, x2, x3, x4, x5, x6, x7. Age is 16 to 30. So symptom of leg disease, which is LEMS. So that is parameter is 50 here. 0, 1, 20 to 25, 1 to 25, 26 to 49, 26 to 49, 26 to 49. Walking is yes for x1, x4 and s6. No is for x2, x3, x5 and x7. So now try to find the indissimilarity relations of with respect to age. So age same x1, x2 and s6, x3, x4 and x5, x7. Indissimilarity relation of LEMS. So that is x1, x2, then x3, x4, x5, x6, x7. Indissimilarity relation of age and LEMS. So try to understand these are unique. So that is x1, x2, x2, x3, x4 are the same, and x6 is different, x5, x7 is the same thing. So here the target set x equal to walk yes. So target set is x1, x4, x6. So if you write the lower approximation, so completely within the target set, which is x1, x4, so x3 not, so x4 will be not there, so x6. And upper approximations, these are not intersection, not null set, so it will be x1, x3, x4 and x6. So that is the lower approximation, upper approximation, and boundary region is the difference between these two, as it is not null set, so x is the rough. Outside the region is universal set minus upper approximation, which is x2, x5, x7. So here the region, so first one is the lower approximations, then this is the upper approximation, the whole rectangle. This region is known as the boundary region, and this is the outside region. So here the x3, x4 as the yes, no, and rest at the outside. So upper approximations is the target set and the equivalence class is not equal to 5. Lower approximation at equal totally subset of x, and boundary region is difference between these two. So you try to solve this thing again for, we have solved it for walking is condition is yes, you solve the same question by walk condition is no. So try to understand another example. So here are the 8 persons, P1, P2, P3, P4, P5, P6, P7, P8. The age of P1 is 25, income is high, purchase condition yes. For P2, age is 30, income medium, purchase condition is no. P3, age 35, income is low, purchase condition is no. P4, age 40, income is high, purchase condition is high. or yes, then P5 22 low, it is no. 28 medium, yes. 33 high, yes. 27 low, and partial condition is no. So try to find you all the things we try to find indicity relations of age, indicity relations of income, and indicity relations of age and income. We try to solve these things. Now we try to solve these questions. We try to find lower approximation of upper approximation of the set B, and the target set is yes. So try to solve this question. Indicity of income. So income is P1, P4, P7 is high. So these two are mediums. If you want to check it. So high is for P1, P4 and P7. Medium P2, P6. Low is P3, P5, P8. So that is indicity of the income. Target set for purchase is yes. So that to find the lower approximations. So lower approximation is complete P1, P4 and P7 complete within the target set, and P6 is there but P2 is not there, so that will not be, so this will not be. So lower approximation is P1, P4 and P7. Upper approximation is this non-null set, so P2 and P6 will be included, so P1, P2, P4, P6, P7, and boundary region for yes, that is P2 and P6. Similarly, target set is no, so that will be P2, P3, P5, P8. So lower approximation completely subset, so P3, P5, P8 completely subset, and upper approximation is P2, P3, P5, P6 and P8. So if you write here, so you can write there that lower approximation purchase power is no here, or purchase power is no, lower approximation is P3, P5, P8, and upper approximation for purchase power is no. So that is the region P2 and P6 including these things. So here the purchase power you can say the not yes or no, and this is the outside. So this is outside means P1, P4 is outside. So that is the concept. So today in this class we have understood the lower approximations, upper approximations, boundary regions. Then we have learned if boundary region is not equal to null set, the set is rough. If boundary region is equal to null set, then the set is creep sets. So question is that assume any decision table, try to find boundary region. So here if I give you one question, so like that. So the question is that let's the objects are x1, x2, x3, x4, x5, x6, some objects A and B, and that the decision D. So here you can write it 1, 1, 1, 2, 3, 4, 5, 5, 6, 7, 8, 6, 7, 8, 5. Decision is yes, no, yes, yes, no, no. So from there, try to find the boundary region, lower approximation, upper approximation, etc. So these are the references of today's class. Thank you.